One of the biggest differences between a regular CAD designer and a skilled one is within their abilities to use the sketch environment. It is not only about drawing a 2D sketch and then convert it to the 3D parts, but also the solutions to so many problems is laid within this environment. Whether you want to fix the errors or having an optimized design tree, or for example editing and working on your model's geometry, you have to do it in this environment. Today we want to model a part which is a sketch is complicated enough to show you the most important sketching tools, yet simple enough that even if you are a beginner, you wouldn't have any problem following it. What's up guys, I'm back with another one. If you're new, I am Moin, a mechanical engineer, your SolidWorks tutor, and we're about to start the third session of SolidWorks tutorial for beginners. Today's project is a special one. We'll be modeling a gear from scratch. FYI, there is a huge library in SolidWorks including a wide range of standard parts such as gears, bearings, screws and nuts and many others, and we can call our particular gear from this library, but for educational purpose and to boost our skills, we'll be modeling this step by step. The hard way, the fun way. Before we dive into the modeling, let's take a quick look at some gear fundamentals, just enough to help us design it properly. If you already know the basics, feel free to skip to the modeling part. In case you're serious about learning SolidWorks, make sure to hit that subscribe button so you don't miss what's coming next. Alright, let's go have some fun. A gear is a mechanical component with teeth that meshes with other tooth parts to transfer torque and motion between different parts of a machine. They are essential whenever we want to adjust the speed, direction, torque, or motion precision. Some of the most important applications of the gears can be found in devices such as watches, vehicles, wind turbines, industrial machinery, robotics, and some aerospace systems. Essentially, whenever controlled motion and power transmission are required. We have different types of gears. The simplest and the most common type is a Spur gear, which teeth are straight and parallel to the gear axis. They are easy to manufacture and efficient at low speed, and they are being used when the shafts are parallel. This is the gear type that we designed today. A helical gear has a teeth cut at an angle relative to the gear axis. The teeth engage gradually and smoothly, so they transfer the power more quietly and smoothly than Spur gears, and they can be used for parallel and cross shafts. We also have some other types of gears like bevel gear, the teeth cut on a conical surface, worm gear, a screw-shaped gear meshes with a worm wheel, rack and pinion, a circular gear meshes with a linear gear, and planetary gear. Multiple gear rotate around the central sun gear inside the internal gear, just like the solar system. For better modeling, it is important to understand what each part of a gear is called, or what's commonly known as gear nomenclature. The first one is module. Module is a unit of size that indicates how big or small the tooth is. As module increases, the tooth size increases as well. And only gears with the same module can interact with each other. For our gear, the module is 1.5. Pitch circle is an imaginary circle when the gear teeth mesh. So we can say that the gears are meshing with each other, their pitch circle are tangent. The diameter of the pitch circle is called pitch diameter. If you multiply module by the teeth number, you can obtain pitch diameter. For our gear, the module is 1.5 and the teeth number is 29. So we can say our pitch diameter is 43.5 millimeters. Circular pitch is the distance between the corresponding points of the adjacent teeth measured on the pitch circle. In order for the gears to mesh correctly, their circular pitch must be equal to. Circular pitch or CP can be calculated by a division of circumference of the pitch circle by number of teeth. From the previous equation, we can say that d divided by z is equal to m, so CP is equal to module multiplied by p number. In our case, it is 4.7. Tip circle or addendum circle obtained by connecting the tooth tips of the gear. An addendum is a distance between the pitch circle and tip circle. Summation of pitch diameter and double m is equal to tip diameter, so we can claim that addendum is equal to m. In our case, addendum is equal to 1.5 and tip diameter is equal to 46.5 millimeters. Root circle or dedendum circle can be obtained by connecting the roots of the teeth of the gear. And dedendum is equal to the distance between the pitch circle and root circle. We can find the root diameter by subtraction of 2.5 multiplied by m from the pitch diameter. So we can conclude that dedendum is equal to 1.25 multiplied by m. The pressure angle is the angle between the line of action and a line tangent to the pitch circle at the point of contact. The pressure angle is usually set to 20, however it used to be 14.5. And finally, the tooth depth is the summation of addendum and dedendum. Alright, now that the theory is clear, let's hop into SolidWorks and start modeling. Open a new part document and go to the sketch mode of the top plane. We start by drawing the pitch circle. So select the circle and start from the origin. And if you remember, the diameter was 43.5. The pitch circle is an imaginary circle and it is not part of the main sketch. So click on it and make it for construction. Next, we should draw the tangent horizontal and the pitch circle. So select the center line and activate midpoint line and go to the origin. If you go vertically up to this point, then start from here and draw a horizontal tangent. Just make sure that the rectangles representing horizontality and tangent is next to the pointer. Next, we should draw the line of action, and we know that the angle between the line of action and this tangent is 20. So select the center line again and start from this point and end somewhere on this circle. And use the smart dimension, select this line and this one, and the angle is 20. Next, we should draw the base circle from which the involute profile of the gear is generated. The base circle is tangent to this line, so select the circle and start from the origin, and if I hover to this line, it makes the circle and the line tangent. Click on it and then click on OK. And also we need to draw the perpendicular bisector of the line of action, so select the center line again and start from the origin, and if I hover the line of action, the midpoint pops up. End your line at this point and then click on OK. Now it's time to draw the gear involute profile. In GearDesign, the involute is a curve traced by the end of a taut string as it's unwrapped from the base circle. Of course, we don't have any string in SolidWorks, so here's what I can do instead. I need to generate 7 other ones of this line here using the circular sketch pattern. Click on it and then click on this line. Uncheck the equal spacing and the angle between line is 5 and number of instances is 8 including the original one, and then confirm it. So just follow my lead until it makes sense to you. Select the center line and draw from each ending point of these lines. For example, this one, just make sure that there is no mates on them, not horizontality or verticality, somewhere in this space. And you can end the line by double clicking on this space and draw from next one, double click, next one, double click, also this one too, this one. I can say that if the string is unwrapping from this point, it can pass through the end of these lines if they are equal to this arc length and they are tangent to it. So here's what I need to do. I need to make this line segment tangent to this arc, and also they should have equal length. And for the arc length, I can use a smart dimension and select the starting point, the ending point of the arc, and then the arc itself. This dimension is driven, click on OK. So it is 1.78. We can conclude that the length of this line is also 1.78. The arc corresponding to this line is this arc, which is twice as big as the first one because this line is generated by using circular pattern. So I can claim that this line should be 1.78 multiplied by 2. Next one is 3 times bigger. Just make sure that you are not selecting the horizontal dimension or vertical dimension. Put it close to the line. And 3 multiplied by 1.78. The next one is 4 times bigger. This one is 5 times bigger, 6 times bigger, and 7 times bigger. And also these lines needs to be tangent to the pitch circle. For making them tangent, select the line and the pitch circle and add tangent to them. Also for this one. I know these steps might be kinda complicated, just so you know it took me several times to draw it correctly. So if you are doing it on your first try, it means that you're a better CAD designer than I am. But in case that you are stuck or confused at any point, drop a comment below so I can help you with it. Now I can say that as the string is unwrapping from this point, it is passing through all these points, and I need to connect them together. And for this I can use a spline and select the points one by one. This one, this one, this one, and this one. And finally press on escape to cancel the selection. So this is our involute. Now it's time to draw the tip circle. So select the circle and start from the origin. And the diameter is 46.5. What is outside the tip circle is extra and we need to eliminate them. And for this we can use trim entities. Click on it and set it to power trim, and you can keep trimmed entities as constructed geometry or not. It depends on you. And it is like this. I need to hold down the left mouse and pass through the lines that I want to eliminate. Like this. So sometimes when we are trimming, it exits the fully defined mode. So I need to use a smart dimension or anything I can use to define it again. For example, I can give a distance between this point and this point to define it completely again. Like this. Now we should draw the root circle. So select the circle again and start from the origin. And the diameter, if you remember, was 39.75. And then I select the line and draw a line from this point. Make sure that it is collinear with this line and it ends with the root circle. Select on this point and then press on escape to cancel the selection. Now we should generate another involute on the other side of the tooth. We can say that the tooth thickness is the half of the circular pitch, which in our case it is 2.35. So for this I need to use the 3-point arc and start on the pitch circle and end on the pitch circle, and it needs to be co-radial with the pitch circle. So I need to make this one coincident with the involute, and by a smart dimension, select the starting point, the ending point, and the arc, and the value is 2.35. What I'm trying to do is to mirror this involute on the other side of the tooth, so I need to draw a line of mirror, and for this I need to use the center line and start from the origin. And if I hover the arc, the midpoint pops up. End your line on it. And here, mirror entities, click on it, and in the entities to mirror, select this spline and this line here, and mirror it about this line. And then click on OK. So we need to make this arc for construction too, because it is not part of the main sketch. And this is our tooth. Now we should trim what is extra in the sketch. So select the trim entities and pass through this line, for example, this one, and also this one. And the base circle is also not part of the main sketch, so select it and make it for construction. And finally there is a hole at the center, so draw another circle from the origin and use a smart dimension and give it the diameter of 8. Back in the features, select the extruded boss. What I need to do is to extrude the root body separately from the tooth. So in the selected counter, select on this part of the sketch here, and the value is 7. Confirm it, and use extruded boss again, open the design tree, and from the boss extruded one, select it as sketch, And in the selected counter, this time select the tooth itself. Make sure the merge result is activated and the value is 7, then confirm it. The reason that I extrude the tooth separately from the body is that I want to generate 28 other ones, and before that I need to apply fillet at the line contact between the tooth and the root body. So select the fillet, and the amount of fillet is 1/6 of the module. And the items, select this one and this one, and then confirm it. Now use circular pattern, and in the direction select this circumference, and number of instances is 29, equal spacing is okay, and in the features select bus extruded 2 and the fillet, and then confirm it. From the drawing I can say that there is an extra feature, which is this one. The outer diameter is 15, the inner diameter is 8, and the value is 10. So select this space and go to the sketch mode. First I select this circle and project it on the current sketch, and then draw another circle from the origin, which its value is 15. In the features, use extruded bus and give it the value of 10, and then click on OK. So this is our gear, and the last step is to apply the material. The material for this body is 1.7225. I leave it to you, you know how to apply the material, and if you don't, just check my previous 2 videos. And finally save the part in the directory of the last 2 parts and name it gear. Close the part and open a new one. Now I want to talk about 3 important features that we didn't have any chance to use them in this project. But before that, smash that like button if you're still with me, and if you're serious about becoming a SolidWorks expert, make sure to subscribe to the channel. The first one is sweep. We use them to create 3D shapes by moving a 2D sketch along a path. So let's go to the sketch of the top plane and use a spline and draw a sketch like this. Just close the sketch and exit the sketch and go to the front plane and use a spline again and draw a path, something like this. So in the features, use the sweep bus. The first one is the profile. Select the first sketch and the path is this. It would be like this. We usually use them to create hoses, tubes, wires, and cables. And of course, one of the most important uses of the sweep is to create these springs. Delete everything and the sketch too. And for the spring, first we need to draw its curve. Open the curve from the features and select helix and spiral. Now it wants you to select the plane. Let's select the top plane. And first we need to draw a central circle. Start from the origin and use a smart dimension and give it the value, let's say 50. If I exit the sketch, in the property manager I can define the parameters. For example, we have different approaches like pitch and revolution, height and revolution, height and pitch. Let's go with height and revolution, and the height is 150 and number of revolution is 10. Also, we can set the starting point or define it clockwise, counterclockwise, and then click on OK. So select the sweep and switch it from the sketch profile to circular profile because we don't have any profile sketch, and the diameter is 5 and the path is this profile. So this is our spring, and then click on OK. That's more like it. The next feature is Loft. Loft feature is to create a smooth transition between 2 or more profiles on different planes. We usually use them to create complex freeform shapes that can be easily be made with simpler features like extrude or revolve. So let's delete everything. Now let's go to the top plane and draw a circle. For example, its diameter can be 400, and then exit the sketch And from the features, use the reference geometry and select the plane. And open the design tree and select the top plane to draw another plane which its distance is, let's say, 400. So go to the sketch of the new plane and draw another circle. And its diameter, let's say, is 600. I can hide this plane, it is better for visualization. Right click on it and then hide it. And in the features, select the loft bus, and in the profile, select these two circles. It is like this. So if I drag this point, I can give it some kind of a twisted shape, like this. So confirm it. And of course we can add our profiles, but for this we need to create new planes. So select the plane and select the top plane. Let's give it the distance of, for example, 800. And go to its sketch environment and draw another circle somewhere in between the last two ones. Let's say that its diameter is 500. So exit the sketch and hide the plane too. So let's edit the loft. If I want to add the last sketch, it is not in the environment and also it is not in the design tree, it is faded. Here's what I can do. The reason that it happens is that the sketch is after the loft and I need to bring it before the loft. So grab it and bring it up, but it cannot reorder. Change would put the child feature above its parent feature. And the parent feature for this sketch is this plane because it is created on it. So first we need to bring the parent up and then the sketch. And now if I go and edit the feature, it is presented in the environment. You can select it from here or here, doesn't matter. And it is like this. I can grab this point and drag it in different directions. And of course we have guide curve. Let's see what's that all about. Let's delete the loft again and go to the front plane. And use the 3-point arc and draw arc from this point and end here. Draw another one from this one and end on this one. These points needs to be pierced on the sketch, so select it and the sketch and pierce it. Also this one and this one. Let's make them tangent to and use a smart dimension to give them the diameter. For example, this one can be 500. Maybe we can make it 450. Now, if I use the loft again, and in the profile select these sketches, and in the guide curve select this one, and it would be like this. So now you know what guide curve is, then click on OK. The last feature is shell, which hollows out the part. If you click on it and select the faces, those faces will be eliminated. So for example, select this one, and the thickness is 5 millimeters. Let's see what happens. It would be like this. It is some kind of a bowl or a glass, something like that. So let's edit it again and select the bottom face too. It would be like this. And that's everything I wanted to cover for the part environment. Next up, we'll dive into the assembly, so stay tuned for that. If you have made it this far, you're killing it. You let me know if you have any questions in the comments, and if the videos are helpful, make sure to like them, and for the upcoming videos, subscribe to his channel. Thanks for watching, keep practicing from one engineer to another, see you in the next one.